Hello and welcome to the activities for data transmission, and we're going to be looking at types and methods of data transmission. Question 1. Suppose a video conference is taking place between delegates in two different countries. Packet switching is being used to send video and sound data between the delegates. Delegate 1 is in the USA and Delegate 2 is in India. Sound and video is being sent between the delegates using packet switching. Can you remember what packet switching is about? Well, packet switching is a switching technique in which the message, or whatever is being sent, is sent in one go, but it is divided into smaller pieces, and they are sent individually. So if I'm going to move this out of the way a little bit, and I'm going to grab another image. Okay, so we have the American delegate on the left, and we have the Indian delegate on the right, delegate 2. So, and we're going to be using packet switching. Packet switching is a switching technique in which the message is sent in one go, but is divided into smaller pieces and they are sent individually. If we have a look here, we can see that we've got 4 packets. Okay, so the American delegate sends these 4 packets over the network. Now, these pink things on these pink S1, first of all, these are nodes on the network, and these contain routers. And the routers direct the packets into different directions. So we get to this first node and we can see that the packets have been split. So 4 and 1 has gone in that direction and 3 and 2 has gone in this direction. Then when it reaches the next node, it's split again. And 1 goes over in this direction, 4 is going down here. In the meantime, 3 and 2 have gone to this node and the packets have been routed in this direction and in this direction. And it carries on and carries on and carries on around the different nodes until it gets to the destination here, and then the packets need to come back and need to be rearranged in the correct order. At the moment, they're not in the correct order. That's how packet switching works. Basically, we take a packet and we split it into little packets and send them all across the network. It's generally a faster system and more efficient way of doing it rather than having one great big giant file that's been sent across a network. Okay. So, I'm just going to clear this off and we'll go back to the question. Okay, so the question is, any potential problems with sound and video quality, and then how these problems could be caused? Well, first of all, we're sending over video and sound, so any potential problems with sound and video quality, the video and the sound may become out of synchronization, the packets arrive at different times. So that's one. Yes, there might be pauses in the video due to time delays when reassembling the packets. There may also be degraded video and sound quality, which is caused by competing traffic on the communication links throughout the network. And yes, there may be a possible dropout, whereby the packets take too many different routes and some may get lost along the way. Or the hop value might reduce down to 0 and therefore the packets are deleted. Question 2. Explain how packet switching could be used to download a large web page from a website. Well, again, we've explained this. The web page is divided into data packets. Each packet has an IP address of the destination where it's going to. The router checks the header against the IP address to send it in the correct direction. The hop value is checked to see if if it hasn't reached 0. And if it had reached 0, then it would have to be requested back from the sender to send it again, and then the destination reassembles the data packet to rebuild the web page. And that is it for question 2. Question 3. The trailer in a packet will use one form of error checking. Explain what is meant by cyclic redundancy check. B. The payload contains the following data. We'll worry about it in a moment. Explain what is meant by cyclic redundancy check. Okay, well, cyclic redundancy check, CRC, is an error detecting code used to determine if a block of data has been corrupted. In the example above, it will take all the 1 values in the payload and add them together to generate an X number. The X value is stored in the trailer of the packet. The receiving computer carries out the same calculation on receiving the payload, basically adding up all the 1s. If the value matches, data packets have been received error-free. If the value doesn't match, data packets need to be resent. Okay, for part B then, if we count all these 1 values, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. There are 29 times 1 in the payload. Okay, so what's 29 as an x value? Well, if I turn to 29 using the old method we know, I'll put a 1 down and a 16. 29 goes into 16 once, and then how many is left over? 29 take away 16 obviously equals 13. 13 in hexadecimal would equal D. So the value is 1D. Okay? So if the calculated value doesn't equal 1D when it's been added up at the receiving end, then the message will need to be resent. Question 4. Explain. How is it possible for packets to be lost during their transmission across a network? Well, if we look at this, packets keep bouncing around, as we've seen in the previous questions, from router to router and never reach the destination. Also, with the use of hop numbers, if hop number equals 0, basically it's gone down to 0, the packet is deleted and is therefore lost. B. Describe how it is possible for a system to deal with lost packets and prevent them from slowing down the transmission process. Well, again, as we've mentioned in part 1, apply a hop number. Each time a data packet reaches a router, the hop number is decreased by 1. Once the hop number is down to 0 and the destination hasn't been reached, then the packet gets deleted. Okay, and finally C, explain why you think packet switching might improve data security. Well, each packet takes a different route. Therefore, if a packet is incepted, hackers still won't have the whole message. So they might be able to get parts of the message, but with it being split in so many different ways, it will be very difficult, if not impossible, for a hacker to receive the whole message. That is it for the first question in topic 2, data transmission. Until next time, thank you very, very much indeed. Please subscribe, please hit notifications so I can tell you when the next video is out. Thank you very much indeed. Bye for now.